Percentages are everywhere in our daily lives, from calculating discounts at the store to understanding statistics in the news. Today, we'll explore what percentages are and how to solve percentage problems systematically. A percentage is simply a way of expressing a number as a fraction of 100. The word percent literally means per hundred or out of 100. Let's visualize this concept. Here we have a grid of 100 squares. If we color 25 of these squares, we have 25%, or 25 out of 100. Now, let's see why percentages are so important in everyday life. Percentages appear constantly in our daily lives. We see them in store discounts, where items might be 20% off. We encounter them in sales tax calculations, and we read them in statistics and survey results. To help you master percentage problems, we'll practice using a multiple choice format, just like you might see on tests and exams. Here's an example of how we'll present percentage problems. We have a clear question, followed by 4 multiple choice options. This format helps you practice identifying the correct answer among several possibilities. The correct answer is B, 12. 15% of 80 equals 12. Don't worry if you're not sure how to solve this yet. We'll cover all the methods and formulas you need in the upcoming sections. In the following sections, we'll learn the fundamental formulas and techniques needed to solve any percentage problem with confidence. Each problem will be presented in this clear, multiple-choice format to help you practice and master these essential skills. The foundation of all percentage problems is understanding the basic percentage formula. This simple equation connects 3 key components that appear in every percentage calculation. Let's break down each component of this formula. The part represents the portion or amount we're interested in finding or working with. The whole represents the total amount or the complete quantity that we're taking a percentage of. The percentage is the rate per 100. It tells us how many parts out of every 100 we're dealing with. Here's a visual example. If we have a total of 100 items, and 40 of them are what we're interested in, then 40 is our part, 100 is our whole, and 40% is our percentage. Now, the power of this formula lies in its flexibility. We can rearrange it to solve for any of the 3 components, depending on what information we have and what we need to find. First, if you know the percentage and the whole, you can find the part by multiplying the percentage times the whole, then dividing by 100. Second, if you know the part and the percentage, you can find the whole by multiplying the part times 100, then dividing by the percentage. Third, if you know the part and the whole, you can find the percentage by multiplying the part times 100, then dividing by the whole. Remember, the most crucial skill in solving percentage problems is correctly identifying which number represents the part, which represents the whole, and which represents the percentage. Master this identification, and you'll be able to solve any percentage problem with confidence. Here's our first percentage problem. What is 20% of 50? We have 4 options to choose from. To solve this systematically, we need to identify the 3 components of any percentage problem: the part, the whole, and the percentage. Now we can set up our equation using the percentage formula. Part divided by whole equals percentage divided by 100. To solve for the part, we multiply both sides by 50. This gives us part equals 20 divided by 100 times 50. Let's calculate this step by step. First, 20 divided by 100 equals 0.2. Then, 0.2 times 50 equals 10. Therefore, 20% of 50 equals 10. Looking back at our options, the correct answer is B, 10. Here's our second percentage problem. We need to find what percent 15 is of 75. We have 4 options to choose from. First, let's identify the components of this problem. We need to find the part, the whole, and what we're solving for. In this problem, 15 is the part, the portion we're comparing. 75 is the whole, the total amount we're comparing to. The percentage is what we need to find. Now we set up the equation. We use the formula, part divided by whole equals percentage divided by 100. Substituting our values, we get 15 divided by 75 equals percentage divided by 100. To solve for the percentage, we multiply both sides by 100. This gives us percentage equals 15 divided by 75 times 100. Let's calculate this step by step. First, 15 divided by 75 equals 0.2. Then, 0.2 times 100 equals 20. So our percentage is 20%. Looking back at our multiple choice options, the correct answer is C, 20%. Here we have our third percentage problem. 8 is 40% of what number? We need to find the unknown whole number from the given part and percentage. First, let's identify our components. The part is 8, the percentage is 40%, and the whole is what we need to find. Now we set up our equation using the percentage formula. Part divided by whole equals percentage divided by 100. To solve for the whole, we rearrange our equation. The whole equals 8 divided by 40 over 100. When we divide by a fraction, we multiply by its reciprocal. So 8 divided by 40 over 100 becomes 8 times 100 over 40. Simplifying 100 divided by 40 gives us 2.5, so we have 8 times 2.5. Finally, 8 times 2.5 equals 20, so the whole number is 20. Therefore, the correct answer is B20. We can verify this. 40% of 20 is indeed 8, confirming our solution is correct. Now we'll solve problem 4, which deals with percentage increase. This is a common type of problem where we need to find how much something has increased as a percentage of its original value. Here are our multiple choice options. We need to determine which percentage correctly represents the increase from $20 to $25. Let's solve this step by step. First, we need to calculate the actual increase in dollars. This is simply the new price minus the original price. The increase is $5. Now we need to apply the percentage increase formula. The percentage increase equals the increase divided by the original amount multiplied by 100%. Now we substitute our values into the formula. The increase is $5 and the original price is $20. 5 divided by 20 equals 0.25. When we multiply by 100%, we get 25%. Therefore, the percentage increase is 25%. Looking back at our options, this corresponds to choice C. The correct answer is C, 25%. Now we'll solve a percentage decrease problem. When a price decreases from $50 to $40, we need to find the percentage decrease. First, we calculate the actual decrease by subtracting the new price from the original price. $50 minus $40 equals $10. Next, we apply the percentage decrease formula. The percentage decrease equals the decrease amount divided by the original amount, then multiplied by 100. Now we substitute our values. $10 divided by $50 equals 0.2. When we multiply by 100, we get 20%. The percentage decrease is 20%, so the correct answer is option C. This demonstrates how to calculate percentage decrease using the original value as the base for comparison. Here we have a percentage of a percentage problem. We need to find what is 50% of 20% of 100. This type of problem requires us to work step by step, calculating one percentage at a time. The key to solving this is to work from the inside out. First, we need to calculate 20% of 100, then take 50% of that result. Step 1. We calculate 20% of 100. Using the percentage formula, 20% of 100 equals 20 divided by 100 times 100, which simplifies to 20. Now we move to step 2. We need to find 50% of our result from step 1, which was 20. Step 2. We calculate 50% of 20. Using the percentage formula, 50% of 20 equals 50 divided by 100 times 20, which equals 10. Therefore, 50% of 20% of 100 equals 10. Looking at our multiple choice options, the correct answer is B. Here's our 8th percentage problem. After a 20% discount, an item costs $80. We need to find the original price before the discount was applied. Let's look at our multiple choice options. We have $90, $96, $100, or $105. Now let's work through this step by step. The key insight is understanding what the $80 represents after the discount. First, we need to understand what the $80 represents. If there's a 20% discount, then the customer pays 80% of the original price. So $80 equals 80% of the original price. Next, let's set up our equation. Let X represent the original price, then 80% of X equals $80. Now we solve for X by dividing both sides by 0.8. 80 divided by 0.8 equals $100. The original price was $100. Looking back at our options, this corresponds to choice C. Let's verify this makes sense. Let's verify our answer. If the original price was $100, then a 20% discount would be $20 off, leaving $80. This matches the given information, confirming our answer is correct. Here we have a percentage error problem. An estimate is 60, but the actual value is 50. We need to find the percentage error and choose from the given options. Percentage error measures how far off an estimate is from the actual value. It tells us the accuracy of our estimate as a percentage. The percentage error formula uses the absolute difference between the estimate and actual value divided by the actual value, then multiplied by 100%. Now let's calculate step by step. We have an estimate of 60 and an actual value of 50. Step 1. Calculate the error by finding the absolute difference between the estimate and actual value. 60 minus 50 equals 10. Step 2. Apply the formula. Divide the error by the actual value and multiply by 100%. 10 divided by 50 equals 0.2, and 0.2 times 100% equals 20%. The percentage error is 20%. Therefore, the correct answer is option C. The estimate of 60 has a 20% error compared to the actual value of 50. Here's our 10th problem involving combining percentages. We need to find what percentage of the entire group are men wearing glasses, given that 30% of the group are men and 20% of those men wear glasses. This is a classic example of finding a percentage of a percentage. We need to calculate 20% of 30%. Let me show you the step-by-step solution. First, let's understand what we're looking for. We want to find the percentage of the entire group that are men wearing glasses. The key insight is that we need to find 20% of 30%. This means we multiply the two percentages together. Now let's calculate this step by step. 20 divided by 100 equals 0.2. Then 0.2 times 30 equals 6. Therefore, 6% of the entire group are men wearing glasses. The correct answer is option A. Remember, when combining percentages like this, you multiply them together. 20% of 30% means you take 20% of the 30% subset, giving you 6% of the whole group. Here's our 11th problem involving a more complex percentage scenario. A store first increases an item's price by 25%, then offers a 10% discount on that increased price. We need to find the overall percentage change from the original price. Let's solve this step by step using a concrete example. We'll assume the original price is $100 to make our calculations easier. First, we calculate the 25% increase. 25% of $100 equals $25. So the new price becomes 100 plus 25, which equals $125. Next, we apply the 10% discount to the increased price of $125. 10% of $125 equals $12.50. So the final price becomes 125 minus 12.50, which equals $112.50. Now we calculate the overall percentage change. The total change is 112.5u minus 100, which equals $12.50. To find the percentage change, we divide 12.5u by the original price of 100 and multiply by 100%. The overall percentage change is 12.5%. Looking at our multiple choice options, this corresponds to option A. The correct answer is A's 12.5%. Here we have a reverse percentage problem. We know the final amount after a percentage increase, and we need to find the original amount. After a 15% tax is added, the total cost is $115. We need to find the original price before tax. To solve this reverse percentage problem, we need to set up an equation. Let's call the original price X. The key insight is that the original price plus 15% of the original price equals the final amount. The equation becomes original price plus 15% of original price equals $115. We can write this as x plus 0.15x equals 115. We can simplify this by converting 15% to decimal form. 15% equals 0.15, so our equation becomes x plus 0.15x equals $115. Now we can combine like terms. X plus 0.15x equals 1.15x. So our equation simplifies to 1.15x equals $115. To solve for x, we divide both sides by 1.15. This gives us x equals 115 divided by 1.115. Let's calculate this division. 115 divided by 1.15 equals exactly 100. So the original price was $100. Let's verify our answer. If the original price was $100, then 15% tax would be $15. Adding this to the original price, 100 plus 15 equals $115. This matches our given total, confirming our answer is correct. Therefore, the correct answer is B, $100. This reverse percentage problem shows us how to work backwards from a final amount to find the original value before a percentage increase was applied. Here's our 13th problem involving percentages and ratios. We have a class where the ratio of boys to girls is 3 to 2, and we need to find what percentage of the entire class is in the math club. First, let's understand the ratio. For every 3 boys, there are 2 girls. This means if we assume there are 30 boys, there would be 20 girls, giving us a total of 50 students. So we have 30 boys, 20 girls, and 50 total students in the class. Now, let's calculate how many students from each group are in the math club. Step 2. We calculate that 40% of 30 boys equals 12 boys in the math club. Step 3. We calculate that 30% of 20 girls equals 6 girls in the math club. Now let's find the total number of students in the math club and calculate the percentage. Step 4. The total number of students in the math club is 12 plus 6, which equals 18 students. To find the percentage, we divide 18 by 50 and multiply by 100, giving us 36%. Therefore, the correct answer is C. 36% of the entire class is in the math club. Here we have a discount chain problem. An item receives 2 successive discounts, first 20%, then 15%. We need to find the total percentage discount. The key insight is that successive discounts don't simply add up. The second discount applies to the already reduced price, not the original price. Let's work through this step by step. We start with an original price of $100. The first discount is 20%. 20% of $100 is $20, so the new price becomes $80. Now we apply the second discount of 15%. Crucially, this 15% applies to the reduced price of $80, not the original $100. 15% of $80 is $12, giving us a final price of $68. To find the total percentage discount, we calculate how much was saved overall. The original price was $100, the final price is $68, so the total discount is $32. As a percentage of the original price, this is 32%. Notice that if we had simply added the discounts, we would get 20 plus 15 equals 35%, which is incorrect. The actual total discount is 32% because the second discount applies to an already reduced amount. Therefore, the correct answer is A, 32%. This demonstrates why we cannot simply add successive percentage discounts together. Each subsequent discount applies to the already reduced amount, not the original price. Here's our 15th problem involving percentage change with multiple variables. We need to find how the area of a rectangle changes when both its length and width are modified by different percentages. Let's solve this step by step. First, we'll establish our original rectangle with length 10 and width 10, giving us an original area of 100 square units. Step 2. We calculate the new dimensions. The length increases by 20%. So 10 plus 20% of 10 equals 10 plus 2, which gives us 12. The width decreases by 10%. So 10 minus 10% of 10 equals 10 minus 1, which gives us 9. Step 3. We calculate the new area by multiplying the new length by the new width. 12 times 9 equals 108 square units. Finally, we calculate the percentage change using the formula new area minus original area divided by original area times 100%. This gives us 108 minus 100 divided by 100 times 100%, which equals 8 divided by 100 times 100%, which equals 8%. Therefore, the correct answer is A, 8%. The area of the rectangle increased by 8% when the length increased by 20% and the width decreased by 10%. Here's a real-world application of percentages. We need to calculate the total cost of an item when sales tax is added. We have 4 possible answers to choose from. Let's work through the calculation step by step to find the correct total cost. First, let's calculate the sales tax amount. We need to find 8% of $75. Converting the percentage to a decimal and multiplying. 8 divided by 100 equals 0.08, and 0.08 times 75 equals $6. Now for step 2. We add the sales tax to the original price to get the total cost. The total cost is $81. Looking back at our options, this corresponds to choice C. This type of sales tax calculation is very common in real life. Remember, calculate the tax amount first, then add it to the original price to get the total cost. Here's problem 17, a real-world application involving commission calculation. A salesperson earns a 5% commission on sales. If they sell $5,000 worth of goods, how much commission do they earn? Let's look at our multiple choice options. We have A, $200, B, $225, C, $250, and D, $275. Now let's solve this step by step. First, we set up the commission formula. Commission equals rate times sales. Step 2, we substitute our values. The commission equals 5% times $5,000. Step 3, we convert the percentage to a fraction. 5% becomes 5 over 100. Step 4, now we calculate. 5 divided by 100 equals 0.05. Then 0.05 times 5,000 equals $250. Therefore, the salesperson earns $250 in commission. The correct answer is C. Now that we've worked through many percentage problems, let's summarize the key strategies that will help you solve any percentage problem with confidence. First and most importantly, read the problem carefully. Many mistakes happen because students rush through the problem statement without fully understanding what's being asked. Next, identify the 3 key components of any percentage problem: the part, the whole, and the percentage. Understanding which of these you know and which you need to find is crucial. Once you've identified the components, set up your equation correctly. Remember the fundamental relationship: part equals percentage times whole, or part equals whole times percentage over 100. Always double-check your calculations. Percentage problems often involve decimals and fractions, making arithmetic errors common. Take a moment to verify your answer makes sense. Finally, pay close attention to the wording of the problem. Words like of, is, what, find, increase, and decrease are crucial clues that tell you exactly what type of percentage problem you're dealing with. Remember these 5 essential tips. Read carefully, identify the components, set up your equation correctly, double-check your work, and understand the problem's wording. Master these strategies, and you'll be able to tackle any percentage problem with confidence. When solving percentage problems, there are several common mistakes that can lead to incorrect answers. Understanding these pitfalls will help you avoid them and solve problems more accurately. The first common mistake is misidentifying which number is the part and which is the whole. This often happens when the problem statement is confusing or when students rush through reading. Here's the wrong approach. A student might incorrectly think that 60 is the part and 15 is the whole, leading to the wrong calculation. The correct approach is to identify that 15 is the part we're looking for the percentage of, and 60 is the whole. This gives us the right answer of 25%. The second common mistake is forgetting to convert decimal results to percentages. Students often stop at the decimal form and forget to multiply by 100. Here's what happens when a student forgets the conversion. They calculate correctly, but give the answer as a decimal instead of a percentage. The correct approach gives the final answer as 24, which is the actual value we were looking for, not a percentage. The third common mistake involves misinterpreting percentage increase and decrease problems. Students often confuse the original value with the new value. The wrong approach uses the new value as the base instead of the original value. This leads to an incorrect percentage calculation. The correct approach uses the original value as the base for percentage increase calculations. This gives us the accurate answer of 20% increase. To avoid these common mistakes, always double-check your work by asking yourself, have I identified the part and whole correctly? Did I convert my final answer to the right format? Am I using the correct base value for percentage changes? The most important step in mastering percentage problems is consistent practice. Like any mathematical skill, percentage calculations become second nature only through regular, focused practice. Your journey with percentages follows a clear progression. You start as a beginner, struggling with basic concepts. Through consistent practice, you develop skills and confidence. Eventually, you become proficient at solving even complex percentage problems. To help you practice effectively, here are excellent resources where you can find percentage problems to solve. Online websites offer interactive practice with immediate feedback. Khan Academy provides free, comprehensive percentage lessons. IXL Math offers adaptive practice problems. Math Drills has printable worksheets for offline practice. Purple Math gives detailed explanations of solution methods. Traditional textbooks remain excellent resources. Pre-algebra books cover percentage fundamentals thoroughly. SAT and ACT prep books include challenging percentage problems. Math workbooks provide structured practice sequences. Business math books show real-world percentage applications. Here are key strategies to make your practice sessions most effective. Follow these strategies for effective practice. First, practice regularly. Short daily sessions are more effective than long weekly cramming. Second, start with easier problems and gradually increase difficulty as your confidence grows. Third, always check your answers and take time to understand any mistakes you make. Mistakes are learning opportunities. Fourth, look for ways to apply percentage calculations to real-life situations you encounter daily. Remember, mastering percentages is not about natural talent. It's about consistent effort and practice. Every problem you solve makes you stronger and more confident. Start practicing today, and you'll be amazed at how quickly your skills improve. Congratulations! You've completed our comprehensive journey through percentage problems. You've mastered the fundamental concepts that form the foundation of percentage mathematics. You now understand the basic percentage formula, how to calculate increases and decreases, solve real-world applications, and apply effective problem-solving strategies to tackle any percentage challenge. Your learning journey doesn't end here. There are many related mathematical topics that build upon these percentage skills and will expand your mathematical toolkit even further. Consider exploring ratios and proportions, which extend percentage concepts to compare different quantities. Financial mathematics will help you apply these skills to real money situations like loans and investments. Statistics and data analysis will teach you to interpret percentages in research and data visualization, making you a more informed consumer of information in our data-driven world. I encourage you to engage with this content and continue practicing. If you have questions about any of the problems we solved, or if you'd like to see additional examples, please share them in the comments below. Thank you for joining me on this mathematical adventure through percentage problems. Keep practicing, stay curious, and remember that every expert was once a beginner. Happy calculating!